Hello, students. We have a couple of questions here from 13.4. Question 9 was the first one. So here, I did do a short video about this one, but again, as you're looking at this shape, you do want to kind of consider what is the volume of it now? What is this, in this case, I think the surface area. And then what happens if I add another shape on? So as a, let's see here. Let me get my tools out. So yeah, as you're kind of looking at a shape like this, maybe it'd be easier to start with something simpler, like we did kind of back in 105. So start with just a single cube, right? So a single cube, then the surface area would be 6 square units because it has 6 faces, right? Now, if I bring another cube onto the side right next to it, right? So now we got to be thinking here. Well, the first one had 6 cubes, but only 5 of them are now showing. The second one had 6 cubes, but only 5 of them are showing. So this one, the surface area now would be 10 square units. Okay. What if I put a shape, I don't know, underneath it, right? So if I went like this, something like that. Okay. So now, again, this cube would have had 5. Because again, front, back, top, bottom, and right-hand side are open. The one down below here would have 5 because the left, right, front, back, and bottom are open. But this one right here is only going to have 4. So the surface area is 14 units squared. Okay. And then again, you could put another box anywhere you want. So I could put a box here. And if I do that, this 5 becomes a 4, and this becomes a 5. All right. So then that would be 10, 18 units. Okay. But if I put a box under here, it might be different because now this one will become a 4, but the one on the bottom would also have a 4, and the one above it would only have a 4. So it's possible, depending on where I put the additional cube, that the surface area could go up or down, if that makes sense. It may not go up by quite as much. So that's the idea of this problem. And so kind of to think about that. But in the video, I do talk about kind of, I like the idea of looking and seeing all the ones that you would actually see. So if I was seeing the front faces, I would just mark, excuse me, I would mark all of those. So 1, 2, 3, 4, 5, 6, 7, 8 that I would actually see from the top. And if I'm looking from the other side, I would see the same 8. So that's 8 plus 8 would be 16. And then from the top and the bottom, kind of which ones have tops showing. So there's a 1, 2, 3, 4. Here's a 5, and there's a 6, right? So there's 6 tops showing, and if you repeat the process, turn it upside down, you'd have the same piece as well. So that's my recommendation for question number 9. And yep, how does the lateral surface area of a right cylinder change if, okay. Oh, but not 10. 12C. Yeah, 12C is another one I did. I think I hinted to in the homework video where I said, yeah, just extend it. Just extend it. Because you can make the surface area, you know you can get the area of the circle here, and you can get the area of the circle down here. It's the lateral piece that you need that becomes a problem. And so if you do extend it, it becomes more of a full cone. And so what you can do is say, okay, let me take the full cone. I have this other little piece right here that would be my cut piece, but there's the full cone. Find the total lateral surface area. That's the sides. Don't count the bottoms, just the sides. And then come over and say, well, wait a minute, can't I find the surface area of just this piece, which would be the piece that we drew on over here? And yeah, and then do big minus small. And what you'll be left with is the lateral surface area of this shape. which is just, again, this kind of outside ring. Doesn't include the circles. You have to add those on at the end, as you might imagine. All right, 19. Let's take a look at 19. Yeah, very similar. Very, very similar to the last one. My hint would be similar triangles, because that's really what you have. So while this is three-dimensional, take a moment, kind of come over here and just say, what if I broke this straight down, and I brought this straight down, and I brought this over, and I made a right triangle just by cutting straight down the middle, right? There would be a cylinder, but that cylinder would look something like this, right? So here's the cylinder. And base of the cone, base of the cylinder, right? And so we have similar triangles, and we know now the ratio of those. So you can use that to find the height. Wait, we know the height of the cone, we know the height of the cylinder. Yep. So we know the height of the cone, which is this long side, and we know the height of the cylinder. So again, similar triangles with the ratios. Your goal is to find the lateral surface area, which means you're probably going to need this length right here. And there you go. That might be all you need. Oh, it's the lateral surface area of the cylinder. Oh, I was finding lateral surface area of the cone. Okay, so that means I need this part. So yeah, you just need to find this other radius. You have the radius here. So I'm going to put a green check mark by everything you know. You know this one, you know this, and you know this. The one piece you don't know yet is this one right here, that radius of the top piece. But again, it's just ratios once you have your similar triangles. So prove you got similar triangles and set up your ratios. All right, and we got MCs 6 and 7. All right, so this is, again, this looks very similar to what we had above. This is the spinning one, which was 12C. Say it again. Extend the lines up, make it an entire cone, and big minus small. And 7, I did show in the video. I actually cut it out if you watch the video on the homework and kind of show you how to do that. But again, you're trying to find the radius of the circular base of the cone. That's right. So 120 degrees here, which means you know this is 240 degrees. And you could use that with this radius to find the arc length, because that's the only thing we know, which is this right here. So now I've got the arc length. And when you fold this up, that arc length becomes your circumference. Once you know the circumference, you can find the radius. So just remember, this is always true. If I know the radius, I can find the circumference. If I know the circumference, I can find the radius. So it's just a quick equation. Use what we learned in chapter 8. That's it for now. If you need anything else, let me know. Otherwise, have a good rest of your day. Off you go.